Thank you for attending today's webinar on discovering research data links via GESIS LOD Research Graph. I am Anne Jakobsson from the RDA Europe Training Program team. Now let me present you our speaker today. Dr. Benjamin Zapilko is a postdoctoral researcher and lead of the team Data Linking at the GESIS Department Knowledge Technologies for the Social Sciences. He joined GESIS in 2007 after his graduation in computer science at University of Koblenz. While working on several projects, he started his research in the field of semantic web and linked open data. In 2015, he finished his doctoral research on publication and matching of linked open data in the application field of the social sciences at Mannheim University. Benjamin is a member of the steering committee of the Research Graph project and the RDF Vocabularies Working Group of the DDRI Alliance. He was co-organizer of the library track at the Ontology Alignment Evaluation Initiative from 2012 to 2014. So let's start our webinar. Please, Benjamin.
Okay, hello everybody. Thank you for the introduction, Annie, and welcome to my talk at the RDA webinar. Today I will talk about discovering research data links via the GESIS LOD Research Graph. Before starting with my talk, let me give you some background information. The current situation for research data at GESIS is the following. GESIS is Germany's largest research infrastructure organization for the social sciences. We hold several databases with research objects like research datasets, publications, instruments, and so on. And on our webpage, we provide users a powerful and integrated search functionality called the GESIS search. This search allows users for finding all our research objects that we hold in GESIS databases at one glance. The search also allows for finding connections between different research topics, between different research objects like datasets which were cited in publications, for example. However, these connections are incomplete because of the scope of GESIS and its databases. For example, we don't hold bibliographic references like metadata records of publications which we do not have the full text available, or whether it's not connected directly to the research data. And also, a lot of research data sets have no links at all to other research objects. Given that background, our motivation behind this project was twofold. First, how can we enrich and connect the research datasets of GESIS with scholarly information? And second, how can we make this network discoverable for users in the end? Because only then our connected information has some benefit. In the Research Data Alliance, there is a working group on data description registry interoperability, abbreviated DDRI working group. This working group has the goal to enable cross-platform discovery between research data infrastructures. And as you can see on that slide, a lot of international organizations are participating, and also several collaborators from all over the world. The project about which results I want to talk today is the GESIS LOD Research Graph project. This is a project in which we adopted developments that have been elaborated in that DDRI working group. In particular, the Research Graph, which is an open collaborative effort towards connecting scholarly records across global research repositories. In that graph, we have, for example, research objects like researchers, we have datasets, we have publications and grants, and they are all related to each other and can be connected to each other in order to provide a fuller picture of the research conducted. The goal of our project was to provide a full picture of connected scholarly information by building this trusted research graph out of GESIS data about the social science research. So what we did was to implement the Switchboard software. Switchboard software is a software that underlies the research graph, if you want to see it like this, and the research data interoperability recommendations, which has also been elaborated by that working group. Let me explain what we have done in particular in that project by introducing a small use case. So imagine we want to do research on national identities in Great Britain. In our institutional GESIS search, we can find interesting research data and publications about that topic. For example, this dataset, the International Social Survey Program with a focus on national identity. We scroll down the results screen. Sorry for this. We scroll down the results screen and we can see there are some linked publications that refer to this dataset. 15 in total. We can check all these publications and then we realize that there is no publication of the data for Great Britain, although it's an international survey. At least we cannot find a publication in this GESIS database. So, however, since it is a known and international study, we are quite sure that there must be some analysis, some publications which have been made out of this study for particular countries like Great Britain. So after searching at Google, this is one possibility, or checking all the researchers' profiles at ORCID, this would be the other possibility. So we check the principal investigators and we can see, okay, there is at least one researcher, in our example, Miss Alison Park, who investigated in that study and published also articles about the results for Great Britain, as you can see in her ORCID records. Of course, this is a very time-consuming search to get to relevant information like this. So with building the research graph, we are able to find these connections and make them available for discovery. While our original database only holds particular connections to our research objects, we are with the research graph service able to augment the graph, which means we are able to find the corresponding ORCID record of this researcher with all its connected publications. In this particular case, we are able to find more publications from the researcher Alison Park, who also participated in our selected research data set, the ISSP survey. With the augmentation process, all publications that are linked to her ORCID record can be connected now to the GESIS graph. Please keep in mind that this does not mean that all of her publications are directly connected to that particular research data set, which was our starting point, but there is a connection which goes via her researcher profile. The result can be seen as a distributed graph where the different research objects from different databases, from different organizations are connected with each other without leaving their physical home. These graphs can be made available for users, for example, integrated into search and discovery systems. Now let me show how this augmentation process exactly works. So in the first step, we have the GESIS data. This is originally in JSON format and comes out of a search index. What we have done is we have converted the GESIS data into a Neo4j graph database. We want to build a graph, so that was reasonable to transform the data before into a graph, store it into a graph database. In a second step, the graph can be augmented. This is done out of the graph database, and we will use the research graph service. This service allowed us to link resources out of our GESIS data to other resources which are in the research graph service already registered. In our case, we did a linking to ORCID records in order to find IDs from researchers. But the research graph service also allows linkings to Crossref, Scholix, to DataSite, and of course also to all already existing augmented graphs. In the third step, this augmented graph is then again stored in a Neo4j graph database, and it can be then used for visualization and discovery purposes. For example, by creating an optimized graph ML file like this, the graph can be nicely visualized, like you can see on this slide on the right side. On this slide, you can see a full visualization of the result of our augmented GESIS graph with research objects from different repositories, mainly from ORCID. I have to mention to this graph that it is only a slice. The full graph from GESIS is a bit more complex, but if we would have wanted to show this, it would be a bit more complicated, and it wouldn't be so nice for legibility reasons. When you take a look at the before and after comparison of the graph, now you can see it clearly that there is a huge difference between the original graph on the left side and the augmented GESIS graph on the right side, especially on the top of the graph, especially on the top and in the right part. You can see a lot of new augmented nodes that haven't been there before, which we gained through the augmentation process. On our website, this graph can be accessed and explored. I will show the link at the end of this presentation to you, so you can try it out by yourself and navigate through the graph. The GESIS graph is still work in progress. We plan also to augment the graph also with additional data sets in the future. What does this mean in numbers? So far in the GESIS graph, we have over 110,000 publications. We have over 6,000 data sets and 53,000 grants. For the publications and data sets, we have also a number of augmented nodes. These are these nodes which are generated and gained through the augmentation process. And also through the augmentation process, we have new identifiers detected from different sources like DOIs, ORCID IDs, or Scopus EIDs. When you take a look now at the numbers, you can see that there is a gap between the total amount of research objects, like 110,000 publications on the one side, and with 8,500 augmented nodes on the other side. This is mainly because of a legacy metadata records at GESIS. A lot of, let's say, a legacy metadata records for, especially in our case for publications, lack of persistent identifiers. They don't have a DOI, they don't have other identifiers. They have an URN, which was heavily used for publications, but the augmentation process of the research graph heavily relies on persistent identifiers like DOIs, because like this, the augmentation and the connection to a new research object can be done. With a larger data set, the numbers of augmented nodes and detected identifiers would be way higher. However, out of this graph, we can now create more statistics and visualizations. Like, for example, you can see on the right side a circle with researchers written around, where you can illustrate who is collaborating with whom. This is a nice visualization which can be made out of the connected information in the graph. What were the lessons learned from this adoption project? First, there are computational requirements, and they are a lot, because harvesting, processing, and transforming large graphs require significant computation power. Second, the data files may be corrupted or incomplete in terms of, for example, invalid characters or different encoding schemes. This becomes even more challenging with large data files because, of course, you need to process them before you upload them to the Neo4j database, before they are further processed by the augmentation step. Third, the persistent identifiers themselves. As I already mentioned during the statistics slide, a large portion of legacy metadata records lack of identifiers, and this is a problem for the research graph service because it heavily relies on the presence of these identifiers. In that project, we did not only want to build a connected graph, we also wanted to experiment with new ways of connecting and reusing research objects. So in recent years, the so-called linked open data became very popular. Now, what is linked open data? Just in a nutshell, basically, linked open data summarizes methods and models for describing and linking data on the web based on standardized web technologies. The most known technology which is used for publishing linked data is the so-called Resource Description Framework, RDF. The interesting thing about this RDF data model is that data is represented in a graph. So this makes all these linked open data sources, from the way they are represented, very interesting for our research graph effort. And also, every single element, not only on a dataset level, but also on metadata field level, every element has its own identifier, which is also very interesting for using it in the research graph. Since in the past years, a lot of data has been published as linked open data on the web, so we decided to be interoperable with these datasets. Publishing our graph as linked open data allows us for extending it easily with relevant resources like additional research objects, additional publications, datasets, for example, or authority data like persistent identifiers from national libraries, which is a huge improvement from national libraries, or additional information, for example, coming from DBpedia, the linked open data version of the Wikipedia. Currently, the GESIS LOD research graph is available as linked open data export only for further reuse in a first version, but we plan to improve and extend the export in the next couple of months with links to other data sources in order to make it a true linked open data set. Linked open data lives out of the links, as it's already the name. Future work for the GESIS graph is, on the one hand, to increase, of course, the number of connected data collections from further repositories, like not only ORCID, but also other repositories, as well as from linked open data. Also, we aim to include controlled vocabularies and organizations, which will again increase the number of links. And this would also allow us to explore the graph over research topics, for example, because sometimes you do not have a particular researcher in mind, you do not have a particular data set in mind, but you want to investigate a particular research topic and want to see what is going on in that particular field of research, what are current data sets there, what are current publications. And in the end, we want to integrate the GESIS graph into our search platforms at GESIS in order to make the graph also available for users, because this is our main objective. While we are doing it, we want to provide a beneficial service for our users. In a first step, this could be achieved by providing the graph as a JSON file in a search index. Like this, it could be efficiently included into a search portal. Currently, the graph is available on a website. I will show you the link at the end of the presentation. And we currently work also on including further data sets, like from SpringerNature SciGraph and from NIH, the National Library of Medicine. Before I finish my presentation about the GESIS LOD research graph, I want to mention two upcoming activities, both at the next RDA plenary in Berlin. We will have a DDRI working group session on Friday, the 23rd of March at 11 a.m. We will do there a live presentation of the research graph, of the GESIS graph, but also a demo of the graph using the graph visualization tool GEFI. And we will discuss the future development plan for a research graph. Also, as a second point, we will have a poster presentation during the coffee breaks in the poster sessions. Finally, many thanks to Nectar. This research was supported by the use of the Nectar Research Cloud, which is a collaborative Australian research platform supported by the National Collaboration Research Infrastructure Strategy. We were able to use their cloud for our necessary computations. With this slide, I want to finish my talk. In the left corner of the slide, you can find the link to our webpage from which you can also access the GESIS graph I just showed you. It's http://researchgraph.org/GESIS. If you're interested in that project, please contact me by mail or visit me at my poster during the next plenary in Berlin. I thank you for your attention.